Welcome to all. Today we will look into epicyclic gear train with bevel gears. First one, Humpad's speed reduction gear. Actually, the usage of bevel gears in epicyclic gear train are very much effective, and the bevel gears are used to make a more compact epicyclic system. And they permit a very high speed reduction with few gears. That is the peculiarity of bevel gears. Then the useful application of epicyclic gears train with bevel gears is found in Humpad's speed reduction gear and differential gear of automobile. Humpad's speed reduction gear is the representation is like this. This is the figure representing in the Humpad's speed reduction gear. In this gear, that gear was originally designed as a substitute for back gearing of a lathe, but its use is now considerably extended to all kinds of workshop machines. Here, in Humpad's speed reduction gear, as shown in figure, the driving shaft X and the driven shaft Y are coaxial. Here, this is the driving shaft X and this is the driven shaft Y. Both are coaxial. The driving shaft carries a bevel gear A and a driven shaft carries a bevel gear E. Here, driving shaft carries a bevel gear A, and this driven shaft also carries a bevel gear E. This is the bevel gear. The bevel gear which is carried by the driven shaft, and this is the bevel gear carried by the driving shaft. The bevel gear B meshes with gear A, also known as pinion, and a fixed gear C. Here C is a fixed gear. The bevel gear B meshes with gear A, also known as pinion, and a fixed gear C. Here there is another bevel gear is at this particular position, which is directly meshed with this bevel gear A and one fixed gear C. This compound gear BD is mounted on the arm or spindle F. This is a compound gear mounted on the arm or spindle F, mounted on this particular spindle F. Then this gear B and gear D both are mounted on the same shaft. Particular gear D is meshes with this bevel gear E, which is on the driven shaft. That is the arrangement of Humpad's speed reduction gear. This is one of the important application of bevel gears in epicyclic gear train. Next, differential gears of an automobile. This is the most important one, which is nowadays using very predominantly. The differential gear used in the rear drive of an automobile is shown in figure. Its function is to transmit motion from the engine shaft to the rear driving wheels and to rotate the rear wheels at different speeds while the automobile is taking a turn. These are the two wheels of the automobile, and this is the rear axle. This one also rear axle P and Q. Then, as long as the automobile is running on the straight path, the rear wheels are driven directly by the engine and speed of both wheels is same. As long as the automobile running in the on the straight path, both rear wheels are directly driven by the engine, and speed of both gears, this wheel 1 and wheel 2, both are equal. But when the automobile is taking a turn, the outer wheel, this outer wheel, when this automobile taking a turn towards right, then the outer wheel, this outer wheel uh, has to cover more distance than the inner rear wheel. This is achieved by the epicyclic gear train in the epicyclic gear train with the bevel gears as shown in figure. This arrangement is known as differential gear of an automobile. Okay. The bevel gear A, known as pinion. This bevel gear is is keyed to the propeller shaft, driven from the engine shaft through universal coupling. This gear A drives the gear B, drives this gear B, also known as crown gear, which rotates freely on the axle, which axle P, which rotates freely on the axle P. Okay. Then two equal gears C and D, are mounted on two separate parts P and Q. C mounted on this particular shaft part, rear axle part, then D is mounted on this particular part. These gears in turn mesh with equal pinions E and F. Here this gear is E and this gear is F. This particular gear C and D meshes with E and F, two equal gears, which can rotate freely on the spindle provided on the arm attached to gear B. Freely on this particular arm attached to gear B, crown gear B. Then when the automobile runs on a straight path, the gears C and D must rotate together. C and D must rotate together. These gears are rotated through the spindle on the gear B. And the gears E and F do not rotate on the spindle. Then when the automobile is taking a turn, the inner rear wheel should have lesser speed than the outer rear wheel, and due to the relative speed of the inner and outer gears D and C, the gears E and F start rotating about the spindle axis and at the same time revolve about the axle axis. We can prove this the velocity of wheel, this outer rear axle wheel is speed of this outer rear axle wheel is greater than this by using this table of motion. Then we can construct a table of motion like this. In that table of motion, first condition, gear B fixed, this crown gear fixed, gear C rotates through +1 revolution. Gear C, this gear C rotates through +1 revolution. Then for gear B, which is fixed, that motion is equal to 0. For gear C +1, that means 1 revolution anti-clockwise direction. Then gear E, the speed of gear E is equal to TC by TE, because here NC by NE is equal to TE by TC. Then this NE is equal to NC into TC by TE. Here NC is equal to +1. Then for gear E, that must be equal to TC by TE. Then for gear D, which is directly meshed with this particular gear E, that's equal to this velocity TC by TE into TE by TD. TE by TD is the ratio of number of teeth on E and D respectively. Then that must be in the negative direction. When this motion of gear is positive, motion of gear D must be in negative direction. That's equal to Tc by Te into Te by Td. We can cancel Te and Te. Then Tc minus Tc by Td, both are equal, because the gear C and gear D both are equal. Then Tc is equal to Td. Then for gear D, that must be equal to -1. Then gear B is fixed. Gear C rotates through plus x revolution. Then again this one is equal to 0. This one is equal to plus x. Then for gear E, plus x into Tc by Te. Then for gear D, minus x, minus 1 into x, that's equal to minus x. Then add plus y revolutions to all the elements. Then total motion for gear B is equal to plus y. For gear C, x plus y. Then for gear E, y plus x into Tc by Te. Y plus x into Tc by Te. Then for gear D, y minus x. Y minus x. Then from this table of motion, we can say that the speed of the outer rear wheel is equal to x plus y, and speed of gear D is equal to y minus x. Here y plus x, then here y minus x. That means the speed of gear C is greater than speed of gear D by an equal amount, which is added in this speed of gear C. That amount must be reduced from this speed of gear D. That means y minus x. Then for gear C, y plus x. Then we can easily prove that the speed of outer rear wheel is greater than speed of inner rear wheel. From the table, we see that when the gear B, which drives the motion from the engine shaft, rotates at y revolutions, then the speed of the inner gear D or the rear axle Q is less than y by x revolutions, and the speed of the outer gear C is greater than y by x revolutions. In other words, the two parts of the rear axle and thus the two wheels rotates at two different speeds. We also see from the table that the speed of the gear B is the mean of the speeds of gear C and D. Speed of gear B is the mean of the speed of gear C and D. Mean of the gear C and D. That means mean of this one and this one is equal to speed of the gear B. Okay, that is all about differential gear of an automobile. We can discuss the more problems about this particular section in the next class. Thank you. Thank you all.